Example 1, parallelograms. So we need to find x and y. Great. So x right here is DBA. DAB. So we're looking for x. X is this angle right there. And ABC is whatever x is plus y together. So ABC is these two. So x plus y right there. That's what we're looking for. Okay, so they gave us OB is the distance from the center to the vertex, to one of the four vertexes. So OB is right there. And it also gave us DB. So DB is the whole thing. OB is half of that thing. If you're not sure, you can just measure it, but by definition, it says the two diagonals intersect in the at the midpoint. So it's saying that OB is half of DB. So OB is half of BD. That means for them to be the same, you need two of those OB. Alright. So OB right here, I'm going to substitute, is 2x plus 10. BD is y minus 10. We're going to distribute here. 4x plus 10 equals y minus 10. I'm going to solve for y. I'm going to put y by itself. So plus 10 on both sides. 4x plus, oh, this is 20 right here. Whoop. So that makes it a 30 equals y. So y equals 4x plus 30. Okay. But then that won't get me anywhere. All I know is this. Now, I know, oh, you can't even see that. There we go. So now I know DAB, and ABC are consecutive angles. Since they're consecutive angles, this one and this one, since they're consecutive, they're supplementary. That means they add up to 180. So let me write this down. So DAB, so angle DAB and angle ABC are consecutive. Therefore, they're supplementary. That means they add up to 180. Alright, so that's what we're going to do. So DAB plus ABC equals 180. DAB, alright, x right there, plus ABC, x plus y right there, equals 180. Combine these two, 2x plus y is 180. Let's just solve it for y, because we're going to have to solve this system right here. So minus 2x from both sides. Notice that I did not put the 2x under 180, because they're not like terms, and I cannot put them together. So these two, I have y equals negative 2x plus 180. Alright. So now we're going to have to solve this. Systems of equations right here. I'm going to give you two different ways to solve this. I'm going to transfer it to another paper. So I have y equals negative 2x plus 180. That's the one that I just found. And I also had y equals 4x plus 30. This is from the very first little system right here, first equation we had. I just put them together. So now, if y equals that and y equals that, that means these two equations equal each other. So I'm going to solve three different ways. This is systems of equations from Algebra 1. So I'm going to solve by hand first by setting them equal to each other. Plus 2x on both sides. 180 is 6x plus 30 minus 30 from both sides. 150 divided by 6. 25. Oh great, I got x. But wait a minute, I need to find what y is. So I need to come back here and substitute x right there. It doesn't matter which one, that's going to give you the same answer. I'm just going to go with the positive just because. Y equals 4x plus 30. 4x, x is 25. 4 times 25, everybody knows it's 100. Y is 130. Alright, so I know my x is 25, y is 130. But that was way too much work to do it by hand. I'm going to show you, since we have that in y equals, a trick in the calculator. So, on the calculator, you're going to go in y1, you're going to type in negative 2x plus 180. In y2, you're going to plug in 4x plus 30. And then you're going to do second trace 5, enter, enter, enter. So y equals negative 2x plus 180, 4x plus 30, second trace 5, wait until it graphs, enter, enter, enter. It's going to give you an error. No sign change means, hey, my answer is outside my window. So you need to go zoom out. And then you do second trace 5 again, enter, enter, enter again. There we go. Now we have x is 25, y is 130. Like we found right there, the hard way, the really long way, when you could have just plugged that in the calculator. Right there. Piece of cake. Not a problem. This one is going to be way easier. So we need to find the coordinates of the intersection of the diagonals. Okay. So I'm going to do it two different ways. One, you guys are going to say that I'm cheating because it's too easy, and then I'm going to show you the math behind that. So I'm going to literally trace the diagonals. Boom. Boom. And find the coordinates of the intersection. I'm looking for that point right there. And that point is 4.5 for x and 1.2 for y. That is it. Now, if I did not have the graph, I could have just flat out used the midpoint formula. So midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I can do the midpoint between these two just because one of them is 0, so it's going to be easier for me. So I'm going to use these two, 9 and 4, x1, y1, x2, y2. So substituting x1 right there, 0 plus x2, 9, divided by 2. y1, 0, y2, 4, divided by 2. 9 divided by 2, everybody knows, is 4.5. 4 divided by 2, everybody knows, is 2. Boom, same answer. There you go.